Welcome to the trading floor. When you are sitting in the exam hall taking your Cambridge physics paper, you are basically making split-second decisions about where to invest your time to get the absolute highest return on your marks. Today, we are opening up the examiner's playbook to master the electron volt, or EV, in Cambridge AS and A-level physics, specifically syllabus code 9702. Now, if you're preparing for these exams, whether it's 9702, 0625, 5054, or any of the others, you already know that quantum physics is heavily tested. It's a high-value asset. In fact, the electron volt as a unit of energy is a critical topic that makes an appearance in literally every single examination series. It is unavoidable. But more importantly, it is highly predictable, provided you know exactly what the examiners are actually looking for behind the scenes. We're going to treat this like a strategic investment.
Now, what's really fascinating here is an insight that completely changes how most students prepare for these papers. Before we jump into calculating formulas or memorizing definitions, it's crucial to understand this direct guidance straight from the principal examiner reports. Top-tier marks aren't just awarded to students who can simply regurgitate a formula they memorized the night before. No way. They are awarded to students who build logical, structured reasoning and actively integrate the electron volt with other syllabus areas. Examiners want to see that you understand the underlying causal relationships. They want to see you connect the electron volt to kinetic energy, to electric fields, to the photoelectric effect. It's not just isolated math. It's a web of interconnected physics concepts, and showing those connections is how you cash in on those top-tier marks.
So, here is our blueprint for today's explainer. We'll be covering the quantum assessment framework, mastering the method mark, systematic processing steps, the top 3 examiner traps, and finally, critical analysis mastery.
Let's kick things off with Section 1, the Quantum Assessment Framework. To really beat the exam, we need to align your preparation with the exact cognitive domains the assessment framework tests. The crucial point here is understanding these 3 pillars: knowledge and understanding, application, and analysis. Now, I see so many candidates hit an absolute brick wall here. They fail to reach those top grade boundaries because they spend, literally, 90% of their revision purely on knowledge and understanding. Think of a student. Let's call him Alex. Alex overloads his brain with raw physics facts, but he brings absolutely zero analysis to the exam paper. To succeed, you have to move beyond that superficial breadth. You need to focus on analytical depth across all 3 of these specific domains of thinking. You need to apply your knowledge of the electron volt to totally novel, unexpected situations and systematically analyze the outcomes. You can't just know what an EV is. You have to know how to use it when the exam throws a curveball at you.
Moving right along to Section 2, Mastering the Method Mark.
This right here addresses the single biggest hurdle for physics students: navigating multi-stage analysis to secure those all-important method marks. This alert comes straight from the principal examiner reports, and let me tell you, it is a massive lifeline. It proves that showing clear working is your absolute greatest safety net in complex quantum physics calculations. Whether you're working out the kinetic energy of an electron in EV or converting back to joules to find a velocity, examiners explicitly note that students constantly throw away easy marks simply by failing to document their process. The method mark strategy dictates that marks are generously awarded for the process itself, independent of the final numerical outcome. It's like an insurance policy for your grade.
Think of the difference between 2 types of test takers. On one hand, we have superficial breadth. We talked about Alex earlier, who just memorizes facts. Now let's talk about Sam. Sam is the speedster. Sam rushes through the paper, mentally crunches the numbers, totally misses the command word requirements in the prompt, and rushes straight to writing down the final answer. If Sam makes a single calculation error, it's a 0. Total wipeout. On the other hand, we have the ideal strategy: analytical depth. This approach ensures every single step is documented on the page. You're capturing those vital method marks, building up your score, even if a stray decimal point at the very end means your final calculation is slightly off. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
That brings us perfectly into Section 3, Systematic Processing Steps.
Because to actually guarantee those method marks we just talked about, we need to implement exactly what the examiners call systematic processing. This is your physics success blueprint. This standardized 5-step sequence is exactly what examiners are hunting for when grading multi-stage quantum physics problems. First, identify the key elements in the prompt. Second, state the relevant principles. Third, execute your analysis with step-by-step clear working. Fourth, verify the results. And fifth, present your final answer in the appropriate format. If you make this sequence a deeply ingrained habit, Your working will naturally earn maximum method marks every single time. Your red pen marks from practice papers will literally transform into green check marks.
Now, within those processing steps, data interpretation is critical. You can break it down into these 3 actionable steps: extract, interpret, conclude. You must extract accurate data from the texts and tables provided. Then interpret the specific relationships between the variables, like how energy in electron volts directly relates to frequency or wavelength in the photoelectric effect. And finally, draw evidence-based conclusions, rather than simply restating the data. You can actually think of this as applying the PEL framework: point, evidence, explanation, link. You make your point by extracting the data, you provide evidence and explanation through your interpretation, and you link it back to the question with your solid conclusion. It's a foolproof way to structure your answers. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's shift gears to Section 4, the top 3 examiner traps.
Despite knowing the proper steps, thousands of students frequently fall into specific traps that are explicitly outlined in the examiner reports. The examiners highlight these exact 3 mistakes year after year. Number 1 is using the wrong approach for the wrong context. This usually means applying a classical physics formula when a quantum approach utilizing the electron volt is required. For example, using classical kinetic energy formulas in a context where an electron is accelerated through a massive potential difference and relativistic effects might come into play, or just mixing up your EV and Joule conversions. Number 2 is forgetting to check format and presentation. This means missing proper headings, messing up your significant figures, or leaving out clear annotations. And number 3 is providing generic textbook answers that are not specific to the unique context given in the exam scenario. You absolutely must anchor your response to the specifics of the question in front of you.
A fantastic way to avoid these specific traps is to use a memory hack. Try creating a personal memory acronym. Make it as weird or as funny as you need to, because you are the only one who has to know it. Whether it's about the factors affecting the electron volt as a unit of energy or the strict conventions examiners demand for presentation, an acronym works wonders. When you are sitting in the exam hall under immense pressure, staring at a complex data source with the clock ticking down, a simple, funny acronym will ensure you don't forget to check your format, your units, and your contextual application before moving on to the next question.
Finally, let's explore Section 5, Critical Analysis Mastery.
To hit those absolute highest-tier grade boundaries, we absolutely must master the highest-order assessment objectives: evaluation and critical analysis. And let me tell you, time management is at the very heart of critical analysis. This right here is your time management matrix. Notice the specific milestones in this deconstruct, solve, evaluate framework. 0 minutes, deconstruct the prompt and decode the command words. 2 minutes, solve systematically using those logical steps we just discussed. 5 minutes, evaluate and make justified recommendations. By consciously managing your time this way, you ensure you don't just stop at the calculation. You actually reserve time at the end to check your answer for reasonableness. It completely prevents that panic-induced rush that leads to unforced errors.
Top-scoring candidates actively demonstrate evaluative thinking, and they do it by consistently hitting these 3 critical benchmarks in their written answers. They don't just blindly accept the data. They question assumptions. They consider different perspectives or alternative approaches. And most importantly, every single decision or conclusion they write down is justified with hard, undeniable evidence derived directly from the provided text or data cables.
This level of critical analysis is especially important during comparative analysis questions. Notice the emphasis on doing both here on the screen. Many students only identify similarities, or they only point out differences. To truly master critical analysis, you must use comparative connectives to highlight both similarities and differences. And again, you must draw conclusions about their relative importance using specific evidence from the exam prompt. You're building an argument, step by logical step.
So, as we wrap up, we've distilled everything down to the number 3. 3 final takeaways from today's explainer on the examiner's playbook. First, you have to decode those command words. Second, apply that structured PEL framework and systematic processing. And third, stick to the time management matrix. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams, your Cambridge success starts here.
Now that you have the examiner's playbook and understand exactly how to secure method marks, avoid the common traps, and demonstrate high-level critical analysis, the only question left is this. Will you let missing method marks cost you your target grade? Will you apply this systematic processing to your next past paper, or will you try to calculate your way to a C when you could have analyzed your way to an A? The choice and your ultimate target grade is entirely in your hands. Get out there, start practicing those cross-topic connections, and I will see you in the next strategy session.